So we're supposed to complete the steps for of a one mean hypothesis test using critical value. So the first thing they're looking for is the null and alternative hypotheses. Okay, uh, you need to read the problem and figure out what the researchers are trying to show with evidence to find out the null and alternative hypothesis. The alternative hypothesis is what the researchers are trying to get evidence for. An investor would like to test the claim that that businesses are reinvesting more than the average of 42% of their profits. Right now, they think it's 42% of their profits go in. The researchers think it's more than 42%. So our rejection region is going to be over here. It's a right-tailed test because being more is being greater than. So alternative hypothesis, you need to put a greater than symbol here. And the null hypothesis is the status quo. And I think actually Newton likes it. No, this should be good. Null hypothesis that it's equal to 42. Alternative hypothesis that it's greater than 42. Let's see what else we got here. Okay, so in that scenario that they just gave us above, they want us to calculate the test statistic. I guess we can leave that. Which they even give you the formula. So this is really just plugging in n equals 20, your sample size, into that formula. The sample mean was 49. The sample standard deviation, S, is 12%. Yeah, because I guess our numbers are in percents. And then 42% of their profits go back into the business. That's the previous mean that we're comparing it to. So mu is 42. Okay, so you can plug all those numbers where they're supposed to go into the formula. And then I'm going to kind of go fast over this part just to keep things exciting. Just do them if you don't get the same number I do, just try to do it step by step. Okay, write it out. 49 subtract 7 over 12 divided by, then find out what square root of 20 is, maybe as a decimal. And then 2 decimal places, so I'm going to round this to a 1 and then kill all these other ones at 2.61. And then they're probably going to make us make an interpretation, huh? Oh, it's one of these dragging ones. Okay. Use the curve below to help visualize your answer. N was 20. I don't know how dragging this thing to 20 is helping us understand math any better. Oh, what is going on here? I don't know what these things are. N is 20. I don't know why this 20 is different than this 20, but let's just leave that for a second. It's a right-tailed test, so let's scroll this down over here. And then our test statistic is not negative 1.19. We just got a test statistic of 2.61, so let's drag that over to 2.61. I'm nervous about this. Why was it saying 120 was different than another 20? There's 2.61. Our test statistic. Oh no, I've got the wrong dragger. I'm sorry. Our test statistic is the red one. 2.61. There we go. And then this is the critical value. That makes more sense. If we have a significance level of 0.10, then a rejection region should be 0.10, or that's good right there. Okay, so that's what the information looks like. I'm nervous about that n equals 20 thing. I hope it doesn't count as wrong just because we didn't get to the right 20. So we need to make a decision. We're going to reject the null hypothesis because our test statistic is in the rejection region. There is strong evidence. Okay, when you get to reject the null hypothesis, it means you have evidence for that alternative hypothesis.